All right, hello everyone, and welcome to Physics 1030. Today we're going to get a little bit of an introduction to physics. We're not going to get too much into problem solving or learning about concepts or equations or anything like that. We're really just going to get a nice overview of physics and how it fits into the world of science. So this is Chapter 1, Physics and the Tools of Physics. We're just going to learn a few basics here. So let's start with just an introduction to physics. I always like to start my classes with a question, and today it's going to be, what is physics? Well, let's go about answering that. If we just take the textbook definition, it says that physics is the study of matter and energy and their transformations. Well, if we think about what's in the universe, well, there's matter and energy, there's dark matter, there's dark energy, and that's everything. So is physics the study of everything? Well, I mean, in a sense it is, but this definition itself is a little bit too broad. So let's start getting a little more specific and see what type of definition we can ascribe to physics. It's a little more practical. So physics, for one, is categorized as a physical science. That's opposed to life science or earth science, which are the other major groups. And in this sense, physical means that it can be measured. It's tangible. You can touch it, or if you can't touch it, you can interact with it in some way. Physical refers to measurable quantities, and we'll see all sorts of these throughout the semester. A few examples I've listed are distance, time, mass, volume. These are things we can go out there into the real world and make measurements of. If you're doing that, this naturally leads to experimentation. If you're going to go make measurements of something, you're probably doing it with some purpose. I mean, partly that is just innate curiosity, but eventually that curiosity is going to lead to very specific things that you're trying to uncover or learn more about. And so when you design an experiment is made to test a hypothesis. And we'll talk a little more about a hypothesis in a second, where I'll give a formal definition. But essentially, an experiment is testing a hypothesis in an effort to either confirm it or deny it. And now, if you run an experiment once and you either confirm or deny, does that end your story? No, it doesn't. In fact, either one of those results doesn't necessarily tell you anything yet. It's only once an experiment has been conducted again and again and again, and you start to see consistent results one way or the other, that you decide to truly accept this hypothesis or to reject a hypothesis. One result, that's called anecdotal evidence. One result, it's encouraging. It can lead you to more thoughts, more experiments, but it's not the smoking gun of evidence that we want. You don't just drop something once and say, okay, gravity pulls on it. Gravity always pulls on things. You do it again and again and again. You start to have a little more confidence in your hypothesis, in your result as being true. So with enough confirmation, a hypothesis becomes theory or law. And I want to take a moment to define these a little more carefully, because these are words that get thrown around in the common vernacular, day-to-day talk, and they don't really necessarily mean the same thing in our casual conversations as they do in a rigorous scientific sense. So when you say, I've got a theory, it's probably not the same as when a scientist says, this is the theory. So first, a law. Well, a law predicts the future from observations. Back to my pen dropping. I know that if I drop my pen, it falls. And so I do it enough times, and eventually we have a law of gravity. We know what is going to happen when we drop the pen. Before I even let go of it, I can predict the future from my previous observations. I know when I drop it, it is going to fall. And that is what a law is. It's sort of telling you what is going to happen based on what you've seen time and time again. Now, a theory is a little more deeper. Theory explains those observations or laws. If a law is what's going to happen, Theory is why it's going to happen. And it is a curious, sometimes frustrating fact that just because we have a law for something doesn't actually mean we have a theory. We don't always know the why behind what happens. And a great example of this is actually gravity itself. We may take it for granted that gravity is well known, well studied. It is in a sense, in the sense that there is a very well-defined law of gravity. We know what is going to happen in a given situation. But in terms of the theory of gravity, we don't have one completely ironed out. There are proposed theories, but there's not a true accepted one just quite yet. There's these theoretical particles called gravitons that physicists have described. It might be some sort of gravitational particle that causes the attraction between things with mass. But that's not 100% certain. And so we do have a perfectly good law of gravity, but we don't actually have a completely understood theory of gravity. The closest thing we have is some of Einstein's work from relativity, curved space, and so on. That's getting way above what we need to talk about today, or probably what we'll even talk about in this course. But that hopefully illustrates the difference between law and theory. And now back to hypothesis. So the exact definition of a hypothesis is an idea with testable predictions. And that testable word is underlined for a reason, because that's the most important part of this definition. Just because you have an idea doesn't make it a hypothesis. A hypothesis is a specific type of idea, one which can be tested to be either confirmed or denied. Now, if I say there's a flying spaghetti monster that lives somewhere in the Virgo cluster of galaxies, I mean, that's an idea, certainly. But is it testable? No. What did it predict? I didn't really predict anything from that statement. There's nothing you can go out there and look for that would provide you evidence for your idea. A good hypothesis or good example would be like the Earth revolves around the sun rather than the sun revolving around the Earth. This was, not well understood, or, they didn't actually know this for a fact way back in ancient history. And whenever you first proposed, hey, I think the Earth actually goes around the sun, you need to then provide, well, if the Earth goes around the sun, we should see these things. And you can go out with a telescope and look up in the sky, and you can observe those things. And you can predict what you're going to observe. You go out, you experiment, and you can confirm that. And sure enough, with lots and lots of experiments, we have confirmed that the Earth revolves around the sun and not the other way around. I try not to pick on them too much, but flat earthers, if you are going to tell me I believe the Earth is flat, well, that is a hypothesis. Give me your testable predictions. And unfortunately, if we go out and test them, we're not going to prove that right. In fact, there are a plethora of experiments I could give you that would prove, in fact, the Earth is round and not flat. If you can give me a testable prediction that we can prove to be correct, that consistent with your picture of the flat Earth, then we can start adopting that as the correct version of things. But until you give me an idea with testable predictions that we can confirm or deny, it's not really a hypothesis. Just saying something because you think it or feel it, that's not a hypothesis. It needs to have testable predictions. You go out and test it. It's either confirmed or denied. We either throw it away or we put it into our treasure trove of knowledge. All right, so we're almost to the end of this first video. One last little tidbit of information I'll include are the branches of physics. And this is really more focusing on what we'll be studying in this classroom. So the major branches of physics are mechanics. This deals with how things move, kinematics, dynamics. Then there's thermodynamics. That has to deal with heat, how heat is transferred between objects. Waves is a major branch of physics. Waves actually encompasses a whole lot. You might just think waves on the ocean, but it turns out waves are everywhere. Sound is waves. Earthquakes are waves. Light itself is waves. Waves are all over the place, and it's a whole branch of physics in and of itself. One of my favorites that we'll get to cover near the end of the semester are electricity and magnetism. The two of those actually go hand in hand. You can't really have one without the other. And lastly, there's a whole branch of physics called modern physics. As the name suggests, this has come about relatively recently. Some of your grandparents, or maybe even your parents, might not have been, or might have been born before modern physics came into place. Modern physics covers things like relativity and quantum physics and atomic physics, and a lot of these things came about, maybe 1940s, 1950s, and onwards. I know my grandparents were born sometime in like the early 1910s, 1920s, 1930s. They were born before any of this even existed. This wouldn't have been on this list whenever my grandparents came into this world. Now, we're not going to get to modern physics. There's a lot of cool stuff there, but that gets a little more complicated. If there's time at the end of the semester, I'll maybe save a class period for some special topics. But we're going to focus on these first four, which are referred to as the classical physics, classical as opposed to the modern, because these have been around for a long, long time, at least 100 years, if not more. And so that's what we're going to focus on in this course, in Survey of Physics, Physics 1030. So, all right, well, I hope this has been a nice brief introduction. We will be back momentarily with another video where we're going to start talking about measurement, because as I said, physical science means we're going to measure things, and measurement plays a huge role in physics. See you soon.